Hello everyone. In this video I'm going to speak about electronic configuration. Let's get started. First of all, we have to identify the relation between main energy level, subshells, and electrons filling them. We will study only the first four main energy levels. Energy level number 1, 2, 3, and 4. We have to know that in each main energy level we have a number of subshells. But first of all, we have K, L, M, N, which are the first four main energy levels. How many subshells we have in general? We have four subshells. We have S, P, D, F. As I just said, we have in each main energy level, we have a number of subshells based on the number of the main energy level. So in the first main energy level, we have only one subshell or only one sub-level. 2, we have 2. 3, we have 3. The fourth main energy level, we have 4 subshells or sub-levels. So as you can see here, in the first main energy level, we have 1s, second, 2s, 2p. It's very important to know that p starts from the second because this number is only reflecting the number of the main energy level. Then we have in the third main energy level, we have 3s, 3p, 3d, and again, 3d starting from the third main energy level because 3 is referring to the third main energy level. Then we have 4s, 4p, 4d, and 4f. I will start to see 4f starting from the fourth main energy levels. Okay, now for the number of electrons. How many electrons in S? How many electrons in P? How many electrons in D and F? Let's see. In the S subshell, we have 2 electrons. Every S. So even if it's in the first or even in the seventh. So we have 2 electrons in each S sub-level. Then we have 6 for P, 10 for D, and 14 for F. And this is, as you can see here, we can see that in the first main energy level, how many electrons? We have 2. In the second main energy level, we have 8. In the third, we have 18. In the fourth main energy level, we have 32. Now we will work to determine the full electron configuration of atoms with up to 36 electrons. As you can see here in this diagram, we have, as we just mentioned, we have in the first main energy level, we have only one subshell, which is 1s. In the second, we have 2 subshells, which are 2s, 2p. In the third, we have 3, 3s, 3p, and 3d. And for the fourth, we have 4s, 4p, 4d, 4f. It's worth mentioning that 4s sublevel, as you can see here, it has lower energy than 3d. As you can see, 4s is filled before 3d because it has lower energy. So we have to care about that. So if we put like a line to arrange the sub-levels according to energy, would write this line. We have 1s2, 2s, 2p. Of course, S has 2, P has 6, then 3s, 3p, 3d, and before 3d we have 4s2, then after 3d we have 4p6. 4s is filled before 3d. Sometimes when you are writing it, if you wrote 3d before 4s, it does not really count as a mistake, but you have to fill 4s first. This is following Aufbau principle. Electrons fill sub-levels from the lowest energy level upwards. This gives the lowest possible potential energy. So if I'm about to give the electronic configuration for N7, I would write 1s2, 2s2. How many electrons now? We have now 4. I have to give the electronic configuration for N7. So I just wrote 4 now. Then after 2s, I'm just following this arrangement. So I have 2p3. Okay, one of you will tell me, oh, you didn't fill 2p. No, I don't have to fill 2p. I just have to finish the number of electrons that I have here. I have 7 electrons. And what I have done now, I have 2, 2, 4 plus 3, so I have 7 electrons, and this is what I should do. Distribute the 7 electrons in the different sub-levels. Okay, we have another way for electronic configuration. It's called condensed electronic configuration, which is to the nearest noble gas. And it will not be clear, or we'll not use it until we move to like bigger atoms. As you can see here for vanadium, V23. The full electronic configuration is just copying this line. We have 1s2, 2s2, 2p6, so we have here 10, 3s2, 3p6, 4s2, another 10, so we have 20, then 3d3. Okay, then we can rewrite it in a condensed form. Instead of writing all this line, which is making 18 electrons, we can just replace it with argon, which is the nearest noble gas to vanadium 23. Then we can continue 4s2, 3d3. So to give the electronic configuration for any element, I would have to use the sub-levels that we have here. So if you just wrote them, you will be able to copy them in the problem or in any question. So to write the electronic configuration for Na11, what you can do is 1s, 2, 2s, 2, 2p6. So we have here 10, then 3s1. Okay, you don't have to fill 3s because you only have 11. You only have 11, and this is 11. If you would like to give the electronic configuration in the condensed form, what you can do, you have to check the periodic table. You will find that the nearest noble gas to Na is Ne10. Then you will write 3s1, because after Ne10 you have the subshell 3s. Okay, so now this is the condensed electronic configuration for sodium 11. What about iron Fe26? You do the same, 1s2, 2s2, 2p6, so we have here 10, 3s2, 3p6, 4s2, 20, then 3d6. Now you have 26 electrons. You can write it in a condensed form using Ar, which is the nearest noble gas to Fe26. Then after Ar, you are writing Ar to replace these sublevels. Then you have 4s2, 3d6. This is the condensed form of the electronic configuration for Fe26.